Hey everybody, Mr. Williams here. There's not really a regular set of lecture notes, or at least a lecture video this week, so I did want to create a little bit of a video talking about the math that is involved in this chapter. So I know math isn't necessarily everybody's strong suit, and I think the information that's in the book, plus what's in the PowerPoint, and what's in the assignment that you actually also have to do this math equation in, I think I have things pretty well laid out where you can understand it. But I thought, why not do a video to kind of show step by step everything you need to do. Again, just in case you do struggle with math and maybe don't quite understand all the steps that were just kind of laid out on paper. So you do have an assignment that utilizes the equation we're going to go through. The assignment is found on page 335 of your textbook. It's at the top in the table. There's actually two equations. There's one for males and one for females, and it's dealing with estimating energy requirement. So what that means is instead of going through all those expensive processes that is talked about in chapter 9 of determining how much energy we use, this is going to give us an estimate of how much energy you use on a daily basis. So, what's the purpose of this? The idea behind this is it's pretty easy. We've done this already in some of the assignments you've had to do. It's pretty easy to determine how much energy you're taking in. You look on your food labels. You can determine, using the information in the back of our book, how much energy you take in. You calculate it out. How many kcals or how many calories do you take in? But what's harder to know is how much energy you're using on a daily basis. And if you're trying to lose weight or balance your intake and your output, it's pretty important to know how much energy you're actually using. So that's what this equation does. It helps us to, again, estimate how much energy you use on a daily basis. So this is showing in a PowerPoint. Let me see if we can get it up here. There we go. So this portion of the PowerPoint, not doing what I want to do here. There we go. This is what you can see in the assignment that I gave you. It's the estimating energy requirements assignment. It's right after the I think it's assignment 8, one that you have due this week anyhow. So this is the information. This has the females or the women's equation on it. What I'm going to go ahead and go through is step by step. I'm actually going to use myself as the subject here, and we're going to go through the male equation and go through these processes that go through this, how to figure this out. So let's go on down to the next page here. So the male equation, 662 minus 9.93 times age, that would be my age, plus PA is physical activity, and that's what's illustrated in these numbers down below here, is physical activity. There we go. That's what I was looking for, is this little laser. So here's physical activity. So I'm going to estimate that I'm, at least here in the summertime, fairly active. So we'll say a 1.25 is what I'll end up using for my physical activity. Then here in parentheses, 15.91 times my weight, but I have to convert my weight into kilograms. And then I'm also going to need my height, but my height needs to be done in meters. So I'm going to show you how to do that as well. Alright, so plug my age in, 41, and then again my physical activity, 1.25. So I've got those plugged into the equation. Next we're going to do my weight. So here's the equation we use to determine kilograms. You take your weight in pounds, divide it by 2.2, there's kilograms. So we're going to plug that in right here. So there's 102.27 plugged into the equation. Next is height. I need to plug that in. To figure out your height, you need to know how many inches tall you are. Well, for most of us, that's pretty easy. 5 foot is 60 inches. So how many inches you are above 5 foot, add that to 60. So I'm 5'9", so that's 69 inches. If you are above 6 foot, 6 foot is 72 inches, and then you have to add on top of that. But you take your inches and multiply it by 0.0254, and in my case that gives me 1.75 meters tall. So we're going to go ahead and plug that in there, and there we have our completed equation with my age, my physical activity, my weight, and my height in metric units. Okay, so order of operations, that's what the main thing we need to remember when we do this type of equation. So I know there's an acronym or like a little song that you can use to, or I've heard that you can use to help with order of operations, but so exponents, we don't have any exponents here. As far as what we have here, things inside of parentheses get done first. After the parentheses, you do multiplication or division. We don't have any division, but we do have multiplication. So you got to do multiplication first, and then you do your addition and subtraction, but you have to do it from left to right. So if there's a subtraction before an addition, when you go from left to right, you have to do that subtraction first. And you'll see that a little lower down as we work through this. So, order of operations, first thing we need to do is work inside of our parentheses. So here's our parentheses. So what we're going to look at is these two pieces inside of our parentheses. That's the multiplication. Multiplication has to be done before addition. So we're not going to be doing this piece. We're not going to add these two numbers together because we have multiplication that has to be done first. So we're going to do that first. Well, actually, we're going to do both of them. So 15.91 times 102.27, that gives us 1627.12. And the other one we did, 539 times 1.75, that is 944.3. Now we can add these two numbers together. Again, we are still inside the parentheses, so we still do this math before we do any of this math out here. Always do what's inside the parentheses first, still following multiplication and division before addition and subtraction. So I went ahead and did this addition, 1627.12 plus 944.3 gives us 2571.42. Since this number is by itself, we do not need to keep the parentheses anymore. You can if you want, there's no need to. So the parentheses are gone. So again, working left to right, we're doing multiplication and division first, which means you can see two multiplication signs. So we have to deal with the numbers on either side of that first. So there's the next step. Do that multiplication next. So as we move down, I did both of them kind of in the same step. So 9.53 times 41 gives you 390.73. And then 1.25 times 2571.42, you do this multiplication, that gives you 3214.275. Now, all of the multiplication is done. There's no division, so we're left with addition and subtraction. Now again, working left to right. You do not want to add these together first. Don't do the addition first. We need to work left to right. First thing that comes working left to right is a subtraction. So let's go ahead and do that, and then we'll talk about what really could happen if you did that backwards. So 662 minus 390.73 gives you 271.27 plus the rest of what we had, 3214.275. Do that addition, and that gives you 3485.55. Now, if you look back up here, if you have a calculator handy, and I can pull one up right here. There we go. Get me out of the way. So if we take, sure I'm on my calculator here, 390.73 and add that to 3214.275, it's 3605.005. So now we would have had 662, sorry about that, 662 minus the 3605.005. 662 minus 3,000, you're going to end up with a negative number. You're going to have negative almost 3,000. Not what we want. So make sure you do this math in the correct order. Alright. So we took 662 minus 390.73 gives us 271.27 plus 3214.275. Add that together. 3,485.55. What? You need to have your labels. I know if you've had math recently, or maybe you remember back when you took math, your math teacher saying you have to have labels on everything. Well, your estimated energy requirement, what do we measure energy in? It is kcals. So make sure you have your label on your answer. So 3,485.55 kcals. Now what does that mean? What is this number? What is it? So what we're finding is, for me, provided I estimated my physical activity correctly, in order for me to maintain my body composition at my current physical activity, I would have to eat 3,400 calories per day. What that tells me is if I want to lose weight, I need to eat fewer than 3,400 calories. And now I can figure that out. I can look at that and I can go, oh, okay, so I need to eat fewer than 3,400 calories per day. Now I add up the number of calories I take in on my food label, make sure I'm only taking in 3,000 or 2,500 calories per day. And another thing I can do is increase my physical activity. Increase my physical activity, that means I'm going to burn more calories and hopefully lose weight also. So that's what this is. It's the estimated energy requirement, the amount of energy required to maintain where you're at. So now on the assignment that you have to do, you have to figure this out for 3 people, yourself plus 2 others. So make sure you keep track of which equation you're using. In this example, we use the male equation because obviously I'm male. If you're doing this for someone else, use the female equation, which was the one that I had at the beginning of this PowerPoint or this video. So escape out of that. And it's on your assignment as well, the assignment that you have to do. So here's the female equation here. So if you have any questions, please let me know. You will have to do this on the test. Make sure you know, I'm not going to provide for you, make sure you know the equations to figure out kilograms and to figure out meters. And then know which equation is the male, which equation is the female, because I'm just going to give you a scenario. It would be a male or a female. They have this certain type of physical activity. They are this weight, this height. You need to figure out which equation to use and be able to figure out kilograms and meters. So again, if you have any questions, please let me know. Shoot me an email or a text or whatever, and I'll do my best to help you out. So until then, have a great week.